Hi, Hi everyone. So let's start the solution of YouTube DPP series for machine learning. So let's see this question. In this question, they are saying for hard margin SPM, the margin is inversely related to mod of W. So let me just remind you that how do we find the margin? Okay. So suppose that you have many plus points here, right? Many plus points here, and or maybe let me take minus here first, and then let's suppose there are many plus points here also, right? Then we say that if you want to find the margin, then let's suppose this is the separating hyperplane, then I should be finding the margin means like I should be finding the distance between this closest point of plus and closest point of minus. So basically this is called margin, right? As you might remember, so this is called margin. Now to find out the margin, if you might remember that we consider this point as x minus the closest point. Okay, these are this x plus and x minus are the actually closest point to this hyperplane, right? So since these are the closest points, so x plus satisfy this equation, wx plus b equal to 1, right? And x minus satisfy this equation, wx minus plus b equal to minus 1. Okay, x minus satisfy this equation. Now what they are trying to say is that if you find out the margin, then margin will be in the direction of w. So if you remember, it was x plus minus x minus, but in the direction of w, which means you need to multiply by w by mod w, right? Now let me go to the next page and let me quickly tell you that how do we calculate the margin. Now to calculate the margin, what you need to do, you need to just solve this, because this is the margin, right? This is the margin, so this thing is a margin. Now you just need to solve this. So basically this is coming out to be wx plus minus wx minus divided by mod w. Now wx plus is basically 1 minus b, right? This is 1 minus b, and actually this is also 1 minus b, wx minus is also 1 minus b, but instead of 1 minus b it is minus 1 minus b. Okay, so this is minus 1 minus b, right, instead of 1 minus b divided by mod w. Now this if you just open this up okay, so let me just open this up. If you just open this up, then what you will be getting is basically 1 minus b, minus and minus will be plus, plus 1 plus b, something like this, divided by mod w. So this is coming out to be 2 divided by mod w, which means 2 divided by mod w is your answer for the margin. So this is called margin. Now since margin is inversely proportional to mod w, so what they are saying that if w2 is greater, so margin will be smaller corresponding to that, right? So the margin corresponding to w1 is larger, so that's why b is the correct answer here. Okay, so you can say b is the correct answer, because 2 upon mod w was the margin, and if w1 is greater, sorry, w2 is greater, then 2 upon w1 is basically greater. Inverse will be greater, right? Okay, now let's move to the next question. So this question is saying that we need to consider the least square solution, and then which of the following must be true, okay, for the unique solution. Now if you might remember that we using the least square, basically we say that we want to find out the solution of by equal to xw, right? By equal to xw. Now since this is not directly solvable, because there need not to be any w exist which directly solve this, so we say that okay, we can have the x transpose y, x transpose y equal to x transpose x w. So basically this is always solvable. It could be having unique solution, could not be having unique solution, but it is always solvable, right? It is always solvable. So now if you find out w, then it will come out to be x transpose x inverse into x transpose y. This is your w. Okay, now if you want to find out the unique solution of this, then this must be invertible, then only you can find out the unique solution, right? So you can say this must be invertible. Now which means in other words, if you want to find out the unique solution, then it means you can say the rank of, okay, in terms of the unique solution, you can say rank of, see, this is basically x is n cross d matrix, so x transpose x will be, this is d cross n, this is n cross d, So that's why X transpose X will be D cross D. D is a feature, okay? I mean number of features. So basically you can say that rank of X transpose X in X, okay? This should be invertible, which means it should be full rank, okay? It is D cross D matrix, should be full rank. So which means that we want this to be D. Okay, so this is the condition. So this is your answer basically. This is your answer. I mean, if you want unique solution, then you need rank of X transpose X to be D. But in the options, the rank of X transpose X is not given. Rank of X, they want to ask in the terms of rank of X, if you notice, right? So you might remember that rank of X and rank of X transpose X are actually same, because their nullity are same, okay, are actually same. These two ranks are actually same. Why? We can easily prove it. I mean, we have done it multiple times in the lectures, but let me just quickly prove it, that these two ranks are actually same. So instead of proving the rank, I am proving the nullity. Okay, so let's just prove, okay, prove that nullity of both matrices X and X transpose X are same. Okay, we will prove using the null space. So suppose this is a case 1. Okay, suppose that V is a vector that belongs to the null space of X transpose X. What does this mean? It means that V belongs to null space means X transpose X multiplied by V is equal to 0, right? Now from here you can say that you can multiply V transpose, this is a workaround, you can multiply V transpose X transpose X V, okay, X transpose X, V transpose X transpose X equal to 0. So this is nothing but XV whole transpose, okay, XV whole transpose into XV equal to 0. So from here you can say XV mod XV square equal to 0, right? Or XV equal to 0, right? I mean, if the square is 0, then finally it is 0. So from here you can say that XV is equal to 0, which means V is also in the null space of X. Basically this is all I want to prove. Okay, if V is in the null space of X transpose X, then V is also in the null space of X. So basically, like I mean, this we have done multiple times in the lecture. I think in the quiz also, in one of the quiz also we have this screenshot. Okay, so anyway, like that's fine. I hope you are trying to understand what I'm trying to say. So I'm just saying that if B is in the null space of X transpose X, then B is in the null space of X, and the reverse is also true, which means if B is in the null space, let me just prove the reverse, which means if V is in the null space, the reverse is actually very easy. So if V is in the null space of X, then obviously you can say that X transpose X V is also 0. If this is 0, then X transpose X V is also 0, which means V is in the null space of X transpose X also, right? So which means we can say that if any vector, I mean they are sharing all the vectors in the null space, which means the nullity must be same, which means the rank must be same. Okay, rank and nullity both combinedly both have number of columns. So if the nullity is same, then rank must be same. Okay, so that's how you can prove it. So I hope the complete picture is clear to everyone, that how do we prove it, right? So rank of X and rank of X transpose X is same, so that's why the final answer is this, but they have not given the answer in that term, so that's why B is the correct answer, because the rank of X and rank of X transpose X are same, so that's why B is the correct answer here. Okay, yeah, so I have given the proof also. Now let's move to the next question. So in this question they are saying that soft margin SVM is given, and then they are saying that if an error on +1 example should be penalized 50 times more than -1 example. So you want to penalize more, okay? Which means that that if there is slight mistake, okay, slight mistake in positive examples, we want to penalize that quite a lot, right? So which means that you will multiply this 50 with the positive examples, positive slacks, right? You will multiply the 50 with the positive slacks by equal to +1. Okay, so that's why B is the correct answer here. Understood? B is the correct answer, because if an error with +1 example must be penalized 50 times more than -1 examples, right? Okay, so let's solve this question. They're asking that gradient points to which direction. See, you might remember from Taylor series. Like, by the way, this question is straightforward and you know the answer, right? So gradient always points to the steepest increase direction, and minus of the gradient points to the steepest decrease direction. But let me quickly prove it. Okay, from the Taylor series, you might remember one thing, that any function, okay, let's suppose you know the value of the function at w and you want to know the value of the function at some other direction. Let's suppose, I mean, w plus u, okay, and let me write eta u. Basically in the direction of u I'm just moving eta, okay, very small step I'm taking in the direction of u. Then you can approximate this function with the Taylor series, which is lw is known to you and you want to find out the value of this, right? So lw plus you can say it will be eta into u transpose gradient of lw, right, at w, and plus the second order terms will be there, but let's not worry about those because it will be eta square by 2 and so on. Okay, so basically if you want to know that in which direction I should be increasing, okay, then in that case you want this thing, or if you want to know decreasing, I mean, depends on you. So basically if you want to know increasing, so in that case this thing should be greater than this. Okay, so which means if you subtract this, then this should be greater than 0, right? Which means if you say that eta into u transpose gradient of lw should be greater than 0, okay, for increasing, okay, in this direction it will be increasing, right? I mean, if this condition is true, then this will be greater basically, or in other words, let me quickly write step by step. Basically this is L of lw plus eta u minus lw equal to eta u transpose grad lw, right? So which means this is the term, okay, if you want this to be greater than 0, okay, for the increasing obviously you want this to be greater than 0. So in that case you can say that eta will be going to the 0 anyway, like u transpose, okay, gradient lw should be greater than 0, right? If you want decreasing, then you can say less than 0, okay, if you want decreasing, then you can say less than 0. So when it will be increasing, you want to know the value of u, in which direction you should go, such that this is greatest, okay, in which direction you should be going. So if you are dot producting, okay, two vectors, right? You are dot producting two vectors and you want to know in which direction, like, I mean, this lw direction is anyway fixed, right? Gradient of lw direction is anyway fixed. Now you will say that u direction must be parallel to this, okay? So u should be parallel to gradient of lw, then the greatest increase, the steepest increase will be there. So gradient of lw is the direction which is the steepest increase, right? So steepest increase direction is gradient of lw. So that's why B is the correct answer here. Understood? Now let's solve this question. In this question they are saying this thing is given to you and they are asking what is this thing, right? So let me just remind you quickly that in linear algebra we have seen the projection matrix, right? So how does the projection matrix formula came? Let me just quickly remind you. Then let's suppose this is the column space of A, which means columns of A, and we want to, let's suppose, solve Ax equal to B. Okay, let's suppose B is not in the same space, B is somewhere else, right? Let's suppose B is this is B, right? Now you cannot solve this obviously, then you will project B. So basically let's suppose that instead of solving this, we are basically solving, I mean, we can solve Ax cap, okay, Ax cap equal to B. We can find out the value of X cap, which means what is the closest projection of B. We are taking the projection of B on this columns of A, okay? So Ax cap is basically, you can say, projection of B, not exactly B. I mean, obviously, Ax cap is your final B, and then using that you say this is the projection of B, right? Which means Ax cap will be lying in the same space, right? This is Ax cap, let's suppose, right? So Ax cap minus B will be the error. Ax cap minus B will be the error. So you can say that Ax cap minus B, it will be perpendicular to all columns of A, because this is how the construction is being done. Okay, these things I'm telling you quickly because this is a question answer series and we have seen this in the linear algebra, right? So which means A1, which is a column of A, A1 transpose into Ax cap minus B, okay, should be 0, right? Similarly A2 transpose into ax cap minus b should be 0, something like this. So from here you can say, if you combine everything, you can say A transpose ax cap minus b, ax cap minus x is, you can take x small, okay, because this is just a vector, so not a matrix. Ax cap minus b should be 0. So from here, let me write, you can write like this, that A transpose A x cap minus or equal to A transpose B, right? And from here you can find out the value of x cap. What will the x cap? You can multiply A transpose A inverse into A transpose B, right? You can multiply like this. So this is x cap. Now, but we know the projection of B is basically Ax cap. So the projection of B will be A into x cap. What is the x cap? A transpose. Okay. So x cap is again, yeah, A transpose A inverse into A transpose B, right? This is x cap. Now, if you want to find out the projection matrix, then we will say that, okay, you multiply projection. If you want to find out the projection matrix, then it is a matrix in such a way that you multiply any vector, you will be getting the projection. So basically this whole thing will be the projection matrix, right? You multiply B, you are getting projection of B. If you multiply C, you will be getting projection of C, something like this, right? So this whole thing is a projection matrix. Projection matrix. Projection on the columns of A, right? On the column space of A. So this A transpose A inverse into A transpose, right? This is basically, you can say, projection matrix. This whole thing is a projection matrix. Okay. Now they're saying that what does this generally represent? So instead of A, here we have X, right? If you want to find out the projection of Y, you can multiply by Y. Okay. But this, yes, this is the projection matrix basically. Okay. Now, what does this represent? This is the projection of X on the column space of A. So A is the correct answer. Okay. Projection of X. Sorry, projection of Y on the column space of A. Orthogonal projection of Y on the column, yeah, column space of X or A, whatever, right? So C is the correct answer here. Understood? So that's how you can understand these questions. Okay. So yeah, so we have seen all of this in the linear algebra. I've taken this screenshot from the linear algebra lectures. Okay, projection matrix lectures. So we have seen the projection matrix and all. Okay. So thank you everyone. So that is all.